let's go ahead and go through chapter 3, section 4. Now we skip chapter 3, section 3 from the book. So we're not missing anything. We just don't do that. So let's go right into section 4, which covers exponent operations with exponents. All right, so now this is something that we actually covered before. So this is more a review, I guess. But so we have this thing 5 squared, right? 5 squared. Now the whole thing is called a power. The whole thing is called power. 5 to the second power, that's called power. 5 squared is called a power. All right, and then as you may or may not know, this is called the exponent, right? And the 5, the big number at the bottom, that is called the base. That's called the base, all right? And we're going to talk about, first thing we're going to talk about with exponents is this thing called the product of powers. It's also called the product rule. So, and it goes like this. If multiplying two numbers with like bases, that means the bases are the same. They both have an x, they both have an a, all right? They both have an n, but they have like bases. You must add the exponent. So it's a pretty simple rule. It's very easy to as well. It's also easy to confuse with other rules, but on a surface level, very easy, simple rule because it's just basic addition. That's really what's going on there. So like right here, it says simplify each expression by writing your solution using exponents. So like right here, we've got like bases. They both have a 2. So we're just going to write 2, and we're just going to add the powers, 2 plus 3. We don't really need to go any further than just adding those up. And so you get 2 to the 5th power. All right, so it doesn't ask us actually to work it out. I mean, if we wanted to, we could multiply it out. 2 times 2 times 2 times 2 times 2, 5 times, is 32. But we don't have to do that. We're just writing it out in exponential or exponent form. All right, next one, we've got 5 to the 5 squared plus, or 5 squared times 5 to the 6th. So you're just going to add the 2 plus the 6, which is going to be 5 to the 8th power. That's it. All right, right here, a bunch of y's. All right, now the only thing that you're going to have to kind of keep in mind here is that if it's just a plain variable, right, if there's nothing there, the default power or the default exponent is a 1. All right, so you just add all that up. So you got 8 plus 3, that is 11. 11 plus 1 is 12. 14, 15. There it is. So you got y to the 15th power. All right, on the next page, turn the page. All right, multiplying algebraic expressions with exponents. All right, so when you have that, all right, so for multiplying algebraic expressions with exponents, what we're going to do for this is we are going to multiply the coefficients. Those are those numbers that are in front of the variable terms. Okay, multiply the coefficients, and then you're going to use the product rule, the thing we just did on the page before, for the like bases, where the bases are the same. All right, so let's kind of apply what we just talked about there, which is so for this we're going to multiply the coefficients, right? You just treat those like any other multiplication problem. 7 times -3 is -21. All right, and then when it comes to the like bases, we use the product rule. We're just going to add those up. So that's where it gets a little mixed up, because it's easy to kind of like get confused. Like, what do I do? Do I add these numbers? Do I multiply these, or the other way around? So this is where practice comes into hand. Comes into play. So you got to make sure you practice these concepts. But this is going to be y. You're going to add them up. Y to the 8th power, and that's it. Can't do any more with that. It's just -21 y to the 8th. Okay. Same thing on this one. We're just going to multiply the coefficients. -8 times -5, that is 40. And there's just a 1 there, right? So it's 40 times 1, which is 40. All right, I'm going to write that down. You got 40 as your coefficient. All right, now this has a exponent of 1, so 1 plus 3 plus 2 is 6. So that's going to be 40x to the 6. Okay, now it's important too, I should also make sure you understand like what this expression means. Now this 40 is just 40, right? It's just the coefficient. This x to the 6, now sometimes people confuse, like this 6 has something to do with this 40. It does not. That 6 only has to do with the x, whatever the power of x is. So if x was 5 or something, that would mean it was 5 to the 6th power. But it has nothing to do with the 40, right? I mean, it's attached to an x, which is attached to the 40, but overall, it's kind of its own thing, right? It's just 40x is 6. So you got to keep that in mind. All right, so types of polynomial. All right. So a polynomial. So we're just kind of talking about vocab here. A polynomial is an expression, an algebraic expression, that contains terms with variable parts, like letters, unknowns, but with variable parts that have only positive, all right, and whole, like there's no integers, or not integers, there's no decimals, there's no fractions, but the exponents are positive and they're whole numbers. Because you can have exponents that are fractions, believe it or not. All right, so like right here, like this, 19n to the 3rd power. That's a polynomial. That's a now if we talk about the type of polynomial, that's called a monomial. That's really not a big deal that you know that yet, but monomial meaning it's one term. But right here, like we can have 4x squared minus 6x plus 1. That's a polynomial. That's a trinomial right there. It's got 3 terms. Okay, notice the exponents are positive, right? That one, there's no exponent there, but the default exponent is a 1. All right, and then let me give you an example of something that's not, this is not a polynomial. So you know what to kind of look for. So not a polynomial would be something like, like 3, it could be like negative 3x to the 5th power plus 2x to the negative 4, something like that. And what makes that not a polynomial is this one simple thing right here. It has a negative exponent, okay? So then it is not a polynomial, okay? All right, so we got some more examples here. I mean, this is just a little bit further than what we did earlier, but so you got multiply the coefficients. You got negative 3 times 5, which is negative 15. All right, and then concentrate on those like bases. So you got x squared and we have x to the 1st, right? So add those up. So that this has got a power of 1, right? So that's going to be x cubed, right? That's what that's going to be. And then you're going to have y. So the y's, when you look at the y's here, we got negative 4, right? And you have y to the 12th. So negative 4 plus 12 is 8, right? So if you think about it like that, that was not a polynomial because it has a negative exponent. But when we multiplied it by another polynomial, we ended up with a polynomial. Okay. Now this one we better distribute the 6x to the 4th into this expression. So when we do that, we're just going to do 6 times 8, which is 48. All right, so you got 48. And then x, now this is x to the 1st. So when we deal with these x's, now this x to the 4th, x to the 1st, that makes x to the 5th. Okay? And then we're going to multiply x to the 4th, or sorry, 6 times 2 is 12. So you got plus 12 and multiply the like bases. So x to the fourth, x to the fifth, that makes x to the ninth. Add those powers up. X to the ninth, and then I'm going to write plus negative 2x cubed. And at this point, you really cannot do any more to it. Cannot do any more. All right. Now there's one thing, I don't know if it's a huge deal right now, but a lot of times when you're dealing with polynomials, and I might as well discuss it now, because it is something that happens and you're gonna have to kind of be on the lookout for it. But notice you want to pay attention to the powers. Now these are also called degrees, right? The powers of each term. And a lot of times when you're dealing with polynomial expressions, you want to put the polynomial in descending order, all right? Which means you start with the highest power. The first term should have the highest degree or power or exponent, and the next one should be the next highest power. The next one should be the next, and you keep dwindling down to where it's the lowest. Perhaps it's even just a constant, all right? And so we might as well just do that. So the one that has the highest power is this middle term right here. So I'm going to write that first. 12x to the ninth, okay? And then the next highest is the first term, plus 48x to the fifth. And then the last term, I'm just going to write that minus 2x cubed. All right? It's okay if you don't write plus negative, because it's the same thing as minus.